Okay, so let's talk. When we left off, we were talking about quantifiers. So quick review, write down notes. There are two kinds. Quantifiers, two kinds. There is the universal quantifier, not to be confused with the universal set, it's just called the universal quantifier, and it looks like this. And the other one is called the existential. Try to print neatly. Existential. And it looks like a backwards E. The universal quantifier is red what? What is the upside down red light?
For all.
For all. So if you have room, squeeze that in. For all. And what is the backward E or the existential? For some. Or another way for that one, it might say there exists some. Sometimes that's easier on the tongue for the problem at hand. There exists some. And every single time you have a quantifier, you're going to have a function. Like what? Like S of x we did last time. X is smart. Remember that was a sentence? And it's a function just like functions in algebra, except it's functions with words, statements. And those are called predicates. So sometimes if you hear the word predicate logic, that's what this is. So I'll write that's also on here somewhere. So if in college, oh, you're in college. If next year you hear something, this is also called predicate logic. And it gets really tremendously hard. We're only doing this very, very tip. But it's easy and fun at the very, very tip. So let's practice. Oh, before we practice, one last thing. How do these things negate? So the next thing we want to do, this is the last new thing in your life in this class. Quantifier negation. You need this. You know what? I would add this right to my chart paper. Paper that has a chart on it, I'll put this right on there. So let's say the function is S of x. So the question is, what is the negation? Let's pretend the statement is that. What is the negation of for all x, x has the property s, or s of an x. So I had to put that word. For all x, s of x. What's the opposite of that? If I say for all, so let's say x is smart. Let's just, this will help your brain. Skip a line. Let's say this function means x is smart, and the universal set is people. Let's just pretend. Skip a line because we're going to do the existential quantifier too. So if I had that, and so read to me what that says without the negation. Read to me this thing without the negation. For all
people.
X is people. Remember, you got to have a universal set. For all people, they are smart. Or said conversationally, everybody's smart. Right? Without the not. Out the not. Maybe I feel like I should take it off temporarily for a second. That means everybody's smart, based on how S is defined and based on how X is coming from the set of all people. What's the complete opposite of everybody's smart? Everybody's not smart? No. Well, that's what it says, right? Not everybody's smart. What? Some people are what? Some people are not smart. Do you hear it? Perfect.
But why could it not be?
Because the opposite of everybody's smart is not everybody's dumb.
But nobody said everybody was dumb.
What was yours then? What were you asking? Why
You said
Everybody's not smart doesn't mean that everybody's not dumb.
Right. So the only thing we know, try to stay logical, the opposite of everybody smart is there exists at least one person who's not smart. It only takes one to denounce that statement. If I say everybody, it only takes one counterexample, right, to denounce that. So watch what happens. The negation of a universal quantifier is an existential quantifier. Say it now, I'll say that again. Jada, please put that down. The negation of a universal quantifier is an existential quantifier. Let me read what this says. It is not the case that everybody is smart. It's the same as there exists one person who is not smart. It only takes one, or some. You got that? Make sense? I said that pretty clearly.
You got that.
I got it. Did you get it?
No.
Okay, let me say it again. The temptation is to say the opposite of everybody's smart is that everybody's not smart. And that's not true. So be careful. People will do that. On the side. This is not true. I'll put a question mark. This is not true because this says everybody, this says it is not the case that everybody's smart. This says for all people, they are not smart. And we don't need all of them to be not smart for this to be negated. You don't need some or one. It's like in math, you only need one counterexample for something to be defeated, some statement. Think of a stereotype.
So
Right?
not everybody is smart when it works.
Not everybody's, no, because you put the not first. But what you're actually doing is just reading this. Not.
Why wouldn't everybody is not smart? Why wouldn't that work?
Because that could be the case, but it's not necessary. Remember way back when we talked about necessary and sufficient conditions? That would be a negation, because it turns out that this quantifier right here that says there exists some, there may be all. We just know there exists some. Put your logic hat on. This stuff is a little tricky, but you got to really dig down deep and think logically. If I say, let's use a stereotype. People say, I don't want to mention one that will offend anybody, but let's just say something like a stereotype you hear all the time, like
Rich people are laughing.
or Irishmen are drunks. This is something this is something we always heard growing up. The Irish people have a problem drinking too much. That's not true. But what it is that? See, that's a stereotype. You're supposed to not, Angel, waiting. Oh, you missed a quiz. You missed a one problem quiz. So let's say that statement. So if I come in the room and I say, oh, guess what? Everybody who's of Irish descent has a problem with alcohol. What would it take to negate that statement? Just one Irish person who doesn't. And then my statement is false. You see, it doesn't require that everybody has no problem with alcohol. It requires only that some. No.
So how would you know?
Well, I grew up in the Northeast, and that's where a lot of Irish, well, everybody actually settled in the Northeast. If you look back at our U.S. history, pretty much everybody started in the colonies, right, which is all in New England. And in the Northeast, there's pockets, like everywhere. Like you have pockets of people who are mostly of Irish descent. You have Italian descent. It also makes for really super food, like excellent restaurants. If you walk 2 blocks, it could be in Little Italy. You walk another couple blocks, and you're in Chinatown, so you get all this great food. Like I'm going to be going to New York City for Christmas holidays because my wife wants to see the Broadway play, so we're going to go see the Broadway play. We're going to get tickets to see Hamilton. I know, that's what I said. There's so many people that do this.
I'm gonna go see the Airbnbs.
What are you going to go see?
The Airbnbs.
You are? Nice. So anyway, you get this idea. It doesn't have to be everybody who's a counterexample. You only need one to break and destroy the stereotype.
Do we have to write that?
No, you don't have to write. Oh, but if you're going to write this, now let's make it true. That's the truth now.
Oh.
The negation, so it matters where you put the not symbol, right? You can't be sloppy. That's different than that. So it matters where that not symbol goes. Now let's try to use your brain. This is the last new thing. Wait. What is the negation, do you think, of an existential quantifier? First, before I negate it, just read to me without the negation what that says. Somebody read that.
For some people is smart.
Some people, so to say it conversationally, well, remember, we're always trying to say it conversationally. Some people are smart. If you say it like a computer would, it would say, there are just some people such that those people have the property of being smart. Conversationally, some people are smart. Now, what would be a way to negate that statement? Some people are smart. What would you need? Some people are smart. Now I'm going to negate that. What's the opposite of some people are smart?
Some people are dumb.
No, that's not. It's not going to be some people are dumb. All people are what? The negation of some people are smart is that all people are what? Not smart.
Sorry.
You can just say dumb, I'll let you get away with it. Now look what happened. Look, stare at this. Look what happened. It's the last new thing. So strap in, keep your hands in the cart. We're going down, we're going up the crest of the roller coaster. The opposite of there exists some people who are smart is that for everybody out there, they're not smart. That's the opposite. Process in your brain. The opposite of there exists some who are is that everybody is not.
That's full split.
Yes, they flip. See, good observation. So the negation. So to say this to a small child, as I always say, the negation of a for all is a there exists, and the negation of a there exists is a for all. Or to say big boy and big girl language, the negation of a universal quantifier is an existential quantifier. Captain. The negation of an existential quantifier is a universal quantifier.
Say that one.
You don't have, I mean, you already observed it. It just means they flip, yes. Said to us once on Island, they flip. Got it? Okay, now. Anybody pass out the homework yet? We're going to practice right together. Question? Or are you going to press it on?
No, I'm gonna pass it on.
Thank you very much. Everybody take a look at this sheet. It's actually 2 homework assignments. You're going to start one today. See if we get all of one done in class, and then the other one will be for homework. Let's see how far we get. It starts off not too bad. Let me write down some stuff. We're still No, not this.
You need that.
You need that, yeah.
You need all of it.
You want me in it, though, don't you? Oh, come on, man.
All right. The next section. So this is homework 17. We're going to practice some of these. And the given, it is raining. Wait, it is raining? Well, then that does not need a quantifier.
There you go.
No, that's interesting. That one does not need a quantifier because it just says it's raining. You can mix them up.
You doing the first one? No,
Well, I'm just
no.
writing down the givens right now. The next one is I for G.
All right, so here are the extra ones.
No, we missed F. Okay, F is a frog. Okay, thank you, sir. X, F of X now, you need an X, is a frog. G of X, X is green. I see where this is going. What else? H of X, X is hopping. 2 P's of hopping? Otherwise it would be hoping. And the last one is the given I of X. X is iridescent. Big word. I'm hoping in what's left of class you can do all of these But we're gonna do some together right now. The top half of the sheet, the second half will be homework. Let's take a look.
So basically,
So I'm on homework 17. The sheet should come from a booklet that I created for students in another class, and this happened to be page 15. That's at the top. So don't confuse the page, the homework assignment number. The homework is number 17. We're not gonna use negation yet. We're gonna practice symbolizing.
I have a question.
Yes?
For the ones that's not in class, how are they going to do the homework if they don't have this sheet?
Good question, huh? I guess I should scan it. I guess I'll scan the sheet and put it as an announcement.
Yeah.
That's a good question. Thanks for asking.
You just record it.
Otherwise, they're gonna be dead in the water. Wait till they get to the exam, and there's gonna be a bunch of these on there. Remember, 50%. Did everybody see this? Final exam date and time, 50%, because we're not having a final test in logic. We're not having a test in this chapter. There's no time left. So the logic will be wrapped into the exam. So half of the test, half the final will be logic, the other half will be other stuff. Which is good for you if you've been doing okay on this logic stuff. Then that's a big chunk. That's good. All right, let's look at the homework from the sheet. And all I want to do is I just want to practice with symbolizing, and then we're going to go the opposite way. We're going to have to write down the sentence. So let's just warm up like A, okay? So I'm on 6.1. That's the top half of the sheet. Let's just do A. All frogs are green. By the way, what would be the universal set for this? Let's take a look. Did they give you one? So the universal set, because you don't know if we're talking about frogs, or if we're talking about people, let's just make the universal set things, which means basically anything. Okay? That matters though, because the universal set is frogs, that's different. So let's make the universal set anything, all things, which could include people. You'll see why that's important. So the first statement we're going to symbolize with those predicate functions, that's the word, that's what you would call them. These are predicate functions. First order predicate, second order predicates coming. So how would I symbolize all frogs are green?
Upside down A, X, F, X.
Upside down A, and then what?
X. Oh, you already got it? Oh, FX.
So for all, then f of x?
Wait, G, my bad. G,
Wait, hold on, don't write yet, people.
my bad, it's G.
What does that say? Translate that.
For all frogs.
No, it doesn't. What is x? That's why the universal set matters.
For all frogs.
No. For all what?
All things.
Taylor, what's x coming from? That's why the universal set matters. This says for all things, what is true about those things? Right, so said conversationally, everything's a frog. That says everything's a frog. Get it? So we can't, that's not the answer, right? Because that says, just be clear what I'm saying. Because the universal set is things, not frogs, but anything, people, books, anything. This says everything in the world is a frog. That's not what we're trying to symbolize. But you see why that says that now? Khalees. Are you ready for the answer, or you have a question?
Could F be replaced with the X?
Say it louder because it's loud. It's really noisy in here.
Could F be replaced for X?
Could F be replaced by X?
Yes.
You need to switch these two? I'm not following.
Yeah, we're on the A. We're all frogs.
No, you can't, because X has got to be there. The variable, good question, variable is always going to be X for this set of problems. So what do I want to say? You got the for all part right. For all things, what?
Agree.
No, now don't write this. We don't want to write that. What does that say?
All things are green.
Everything is green. That's not good. In
F.
fact,
You
what
need an F in there though.
Yeah,
The
so-
F has to go after all things.
well, no, you could put an F and a G. So what can we add to that?
Obviously, you have to put the G in there too, but then where does the F go in the equation?
Well, we're trying
It goes before G.
Okay, want to put it before G?
It
Okay.
does go before G.
Okay, so, all right, let's just hear out what you're saying. Don't write until I say it's good. All right, so what would it be?
I'm just saying.
So let's put
All has to
that,
go
so
before
put
G.
that, now what?
G, then you have to put the G after that.
Now I need to connect it.
And.
And? This is a very, very, very super common mistake, and I want to talk about it. Thank you for saying it. Why is this not all frogs are green? Think your hardest.
All these are green and frogs.
Right. So everything is a what? What does that say?
Green frog.
Everything is a green frog. Right? For all things, be logical. Stay with me. This is for everything in the world. It is a frog, and it is also green. Therefore, everything is a green frog.
So then teach us how to make it just talking about.
I am getting there. I'm getting there. Calm yourself, Taylor. I want to make sure people see this. This is what I get on test for this exact kind of problem. So I'm stressing. This says everything's a green frog. We don't want that. We just want to say, if it's a frog, then it has to be green. Uh-oh, what word did I just say?
Conditional.
Ah, so let's fix it.
Thank you.
Well, this is how this is the best way to show you, is to go through the steps of what's logical. So what would you say? If what?
If
Something is a
frog,
something is a frog,
then
then what is true about that thing?
it's yes.
It's green, and you do need parentheses.
Yeah.
Okay? It took a while to get there because I wanted you to see the process your brain goes through. I could have written that down 10 minutes ago.
So we gotta translate it in English or something.
So we're going to do some more, but now this is a huge hint, this first one. They gave you one that was pretty hard at the very first one. If it's a frog, then it's green. An and statement won't work there because then you're saying everything is a green frog. We're only saying that if the thing is a frog, then it's green. Therefore, all frogs are green. Are you with me? If you're thinking, I hope you're with me. If you're spacing out, you're dead in the water, police.
So for that, sorry, fast flowing B, would it be the same thing, the not symbol?
Let's look at B. Let's look at B. We're going to get a couple of these under our belt, and then I'm going to have you try some. And I'm going to try my best to write the answers down quickly, but it's going to take a while. The next one says, no frogs are green, right? My eyes. No frogs are green. No frogs are green. Not just some frogs are green or not green, but no frogs are green. Now just think logically what that means, no, in terms of quantifiers.
Wouldn't it be the same thing, you just add the not symbol in front of frogs? Or would that be wrong?
If it's not a frog, then it's green. No.
No.
No. No frogs
If it's
are
a
green.
frog, then it's not green.
Yeah, you have the not on the wrong part. If it's a frog, then it can't be green, because no frogs are green. Now, one thing we're missing. You can't have something like that ever on your answers. We're missing a big giant thing called a quantifier. Everything has to have a quantifier. Is it for all, or there exists? Some? Is this property talking about all or just some?
It's on the off.
It is. It's talking about all. Good. Let's go through that again. Put your thinking on it. This is arguably one of the hardest parts of math. Is symbolic logic. Even though we're at the very tip of the iceberg, it gets a little hard. You got to really think. So this says no frogs are green. So if it's a frog, we know one thing for sure: it cannot be green. Therefore, how do you write that? Well, if it is a frog, then it cannot be green. And what does this apply to? It applies to all things. You'll get better with practice. But you've got to think, if you do these lazily, meaning your brain is lazy and you write down, you just guess, you'll never get them right. You got to see how you got to really think them through. So and it takes a while. It took me a while and I learned it. Yeah.
Some frogs are
Some frogs are green. That one I want you to just do without me.
That's the same.
What some frogs are green?
The backwards E.
All right, let me do it. No, I think it is a little bit different. Hold on, let's do it. Some frogs are green. This one is actually this is the hardest one of the three because there's another common mistake. So I'm glad we're doing it.
Is it a symbol?
So what symbol?
The backwards E.
Yes, it's going to be an existential quantifier because what tipped you off about that?
It's a sum.
The word some. So we know we're starting off that way. Good. Now this part is the part you got to really think. So read what we have so far.
Some.
There exist some things, that's all we have, Okay, that's what we have so far. There exist some things.
The last part is frogs are
And then
green.
what do we want to say?
If it's a frog, then it's green.
If it's a frog, then it's green.
My opinion. If
Gotta be a little careful here. Let's write down what she said. Don't write yet. Don't write yet. She said, if it's a frog, then it's green.
you need parentheses.
This one went all the way up to the top logicians of the world to talk about why this is wrong, because it seems so right. Why is this actually not right? If I say some frogs are green,
Oh, then
does that mean that, does that imply that there are some green frogs out there in the world, right? That there are some. This does not say there are any in the world. There could be none. Because this is it. This just simply says, if it's a frog, then it's green. But for all we know, there's nothing that's a frog. But this says there are definitely some of them. And they are green. Hard stuff. So it's very small correction. Watch. Very small correction. This is wrong. There exists. Yes, it has to have frog. Yes, it has to have green. What's in the middle?
The 3 line.
No, not 3 line. What? Don't guess. What? Think. No guessing. And. You said that, but you're in the back. I can't hear you. And. Why? Now read it. Now read what it says exactly. It says there exists something,
Some things are
and that
frogs,
thing is what?
and-
A frog,
And they are.
critical word, and it's green. In other words, some frogs are green. Ooh. Is your hat warming up yet? Thinking so hard? This is not easy. I think that, but I want you to think. You'll never get it if you're sloppy or lazy thinker. And I think in some cases, some of you have been lazy thinkers your entire education, and you got away with it, which is not your fault. It's a fault of your education system that you got away with being a lazy thinker and never needing to be a hard thinker. And now I'm asking you to be a hard thinker, and it's hard, right? Not your fault, but it is your fault now if you don't try. Whew. Let's do, I don't know how many more we're going to do together. What time are we having here? We got about 10 minutes? Good.
You say you gonna let us out.
No, I can't. I do what I can, but based on what's going on, Janae, we need the 10 minutes, don't you
Okay,
think?
so can I ask you a question about the next one then?
Yeah,
About
yes,
frogs and rock?
Yeah. So,
Would it be the same?
wait, which one? You're talking about E?
D?
Oh, D, some frogs are not green. Now, let me write it down for good of everybody. Some frogs are not green. Some frogs are not green. Okay, now we got something going on. Okay, now what?
That would be the same equation as before, but you would put the negation before green.
Let's look. So some things exist such that, you can always read the parenthesis as such that helps me. So there exist some people such that, or some things such that. What is true about those things?
Frog.
They're a frog, and
They're not green.
they're not green. Taylor, you got it right. By the way, and is also read as what? People don't realize that, but that might help you write that down. So if I gave you this in words and you have to go the other way and I put in but, that means that's the same as and. Because you're saying they're both happening at the same time, right? I'm glad you came today. This is going to be hard. Well, at least we have something for people who are not here, but this is hard. Any questions with what we have done so far? You need to practice while it's fresh in your mind right now. Okay, so take it from D and try to do the next couple. In fact, get as far as you can. If I have to check homework next time and check 2 assignments, I will. I want you to work on these and I will help you as we see fit.